Hi, Salam Alaikum. I'm James Matul, lecturing mathematics to you today. Please, as you are watching this video, don't just watch alone. Share it with friends and family such that they will also get to learn. As you are watching this video, make sure you subscribe to our YouTube channel such that you don't miss upcoming videos. We have other videos that are coming. So, some Singapore students request us about mathematics, and that's why we have come to start secondary 4 mathematics. And we know you are in condition where you are preparing for national exam, so we will be there supporting you. What you have to do is to subscribe to our YouTube channel and write something to us. Tell us what is bothering you, and we will be there helping you uh, in mathematics. So for today, we are going to start with the complex numbers in Unit 1. Unit 1, complex numbers. So complex numbers are found helpful in finding the square root of negative numbers. Complex numbers are found helpful. They are helpful in getting the square root of a negative number. So the complex number was first referred to in the first century by a Greek mathematician known as Hero of Alexandria when he tried to find the square root of a negative number. But he found it difficult to get the square root of a number. What he just did was uh, changing a negative into positive and take the numeric root value. Furthermore, the real identity of a complex number was defined in the 16th century by Italian mathematician Girolamo in the process of finding the negative root of a cube and quadratic polynomial expression. This one was what that Italian mathematician did. So complex numbers are widely used. They are used in many scientific research. For example, they are used in signal analysis, and they are also used in electromagnetism and in electronics, even in quantum physics and fluid mechanics. So those are the areas of applying complex numbers. Now, when we come to a definition of a complex number, what is complex number? So a complex number is a sum of real number and imaginary number. Complex number is a sum of a real number and imaginary number. So before we go deeply in complex numbers, we need to analyze these problems, the following problems. So from number 1 to number 6. So, and this will let us understand what complex number is. So let's start with the first one. You are being told to explain why root of negative 16 is not a real number. A real number is a set of rational numbers and irrational numbers. So it is a set of rational numbers and irrational numbers. So in normal rational numbers, those numbers that can be simplified under square root, like root of 16. Root of 16 in normal simplification is equal to 4, because when you multiply 4 times 4, you will get 16. You will get 16. So in this one here, you can easily solve this kind of rational numbers. So let's give an example of another rational number. We have the square root of 4. The square root of 4, we normally know it is equal to 2. What about root of negative 16? What is the square root of negative 16? So this one is difficult to solve. It cannot be solved easily. So like it cannot be solved easily like other rational numbers, like other rational set, those of root of 4 root of 16, root of 25, and so on. The knowledge or the concept of complex number is useful in getting the square root of a negative number. Get to understand that as you are going through complex numbers, it will help you in getting a root of a negative number. Root of a negative number. Okay, so root of negative 16 is not a real number because it has negative inside here. It has a negative inside. But a real number is the what is a set of uh, rational numbers and irrational numbers. Okay, let's see number 2 here. In number 2, you are being told to add two brackets. You are adding them. So when you are adding 2x plus 5, when you are adding it to 3x plus 7. So what you do here, you have to collect like terms. 2x will add 3x, then 5 will add to 7. So this one will give us 2x plus 3, then plus 5 plus 7. When you add 2x plus 3x, you are going to get 5x plus 12. So this is the result when you add these two. This is the result when you add these two. So how is this one helpful? This one here, the one they told you to add. So this one is helpful when you are adding two complex numbers later. So when you are adding two complex numbers, you take the same procedures. We said before, complex number is a number that is having two parts, real part and imaginary part. Just be calm. You are going to understand what real part is and what is meant by imaginary part. So when you are adding two complex numbers, you collect the like terms, the real part together and imaginary part together. Don't forget of it. You are going to apply this knowledge later. Okay, what about this here? Here you have x minus 1, then minus 4x plus 8. What you do here, you first open the bracket. So after opening bracket, then now you will make your operation. So when you open the bracket here, you will have x minus 1. So for the case of this, it will affect the sign inside here. It will affect those signs inside. So for this one, since it is positive, it is going to be negative. So this one is going to be negative 4x, and this is going to be negative 8 here. So after working out like this, so you need to collect like terms. X minus 4x together minus 1 minus 8. So what you have done here is that you have separated the x value and the one without x here. Therefore, in conclusion, x minus 4x, this is going to give you negative 3x. Then negative 1 minus 8 is going to give you negative 9. It is going to give you negative 9. So this is the result of subtracting these two. So what does it mean here? This is also helping you to understand how to subtract two complex numbers. When you are subtracting two complex numbers, what you do, you first open the brackets. After opening brackets, you will now collect the real part together and the imaginary parts together. So that is why they are giving you these questions here in the beginning of the topic. So let's see the other number here, the other problem. We have 9x outside bracket 5x plus 6 plus 6. Then so here you are working out Here you are multiplying 9x with this 2 inside in the bracket, because this one are not like terms, so you multiply this 9x by all of them inside. So therefore there you are going to have 9x times 5, it is going to give you 45 x. So since you are multiplying 2x here, like x times x, they become two numbers of the same base. So what are their exponents? Their powers here is 1 1. So what you do, numbers of the same base, you add the powers. 1 plus 1, it is going to give you 2. So here you are going to have 45x square 45x square plus 9x times 6. 9 times 6 is going to give you 54x 54x. So this is final result for this number 4 multiplication. This one is letting you understand how to multiply a complex number. This one is like a complex number by either a complex number where one part is what is 0, where one part is 0. You see, the way we work this one out is the way we work out the multiplication of two complex numbers. So let us work them out. So we have 2x here plus 3 plus 3, then times 7x minus 1. So here you are multiplying the two equations. What do you do when you are multiplying two equations? You first take this first number here and multiply it times this bracket. Or here you are going to have 2x times the other bracket, which is 7x minus 1. Then you take this number with its sign plus 3 times what? Times this bracket, the second bracket, 7x minus 1. So that is how you multiply the two equations. So here you will have 2x times 7x. 2 times 7 is 14. 2 times 7 is 14. X times x will give you x squared. 2x times negative 1 is going to give you negative 2x. 3 times 7x, so you have positive 21x. Positive 3 times negative 1, it is going to give you negative 3. So when you come to this stage, so what you do, you add like terms, like 2x and 21x are like terms. Now bring them together. The final result here is going to be 14. It's going to be 14x squared, 14x squared. Then 21x and negative 2x. The result here is going to give you positive 19. Positive 19x minus 3. So this is the final result here. So when you are multiplying two complex numbers, so you will have this kind of expression at the end. Finally, we have x squared minus 24 is equal to 0. You let x squared remain on the left hand side of the equation, then take this 24 to other side. So when you take 24 to other side, you are going to change the sign. The sign here is negative, so it is going to be equal to positive 24. After reaching this stage, you don't need to get stuck. So put both sides under root. The right hand side and the left hand side. Here root is going to cancel with the square. You see? So it remains as x here alone. This remains as x alone. X is equal to root of 24. Root of 24 is the same as what? Is the same as 4 times 6. Root of 4 times 6. 24 inside there is the result of 4 times 6. 4 times 6 is 24. Since we know like that, since we have that, you will say that x is equal to what? You can put these two numbers under different roots. You say x squared is equal, x alone is equal to root of 4 times, because you are multiplying the two, times root of 6. Finally, you know root of 4. So x is going to be equal to root of 4 is 2, we know it, times root of 16. We don't, I mean root of 6. We don't have root of 6. You will leave it in this form. It will not change anything. So this one will be the final result. X is equal to 2 root of 6. All this one here are letting you understand how you will operate complex numbers at the end. So make sure don't forget about a complex number being a sum of a real number and imaginary number. Number 2, complex numbers are helpful in finding the square root of a negative number. They are helpful in getting the square root of a negative number. Don't forget of that. So complex numbers are used to what? To get some of the quadratic, to get the values of some of the quadratic equations which cannot be solved, which are difficult to solve. Some quadratic equations do not have real numbers solutions. They do not have real numbers solutions because we need to find the square root of a negative number. Some quadratic equations are difficult to solve because you cannot get the root of a negative number. So if I give you one of the example here, if you have this quadratic equation, x squared plus x plus 1 is equal to 0. If you solve this quadratic equation using quadratic formula where you have x is equal to negative b plus minus root of b square minus 4ac divided by 2a. So when you solve this, the value of a here is equal to 1. Then the value of b is equal to 1. Here you can see their coefficients are 1, 1, and value of constant is the same as 1. So for this quadratic equation, you substitute these values. Substitute these values in the formula here. Let's substitute. X is equal to negative b, which is 1, plus minus root of b square, which is 1 square, minus 4 times a, which is 1, and c, which is also 1, divided by 2 times a, which is also 1. So you will have x is equal to negative 1 plus minus root of 1. 1 square is the same as what? Is the same as 1. 1 square is equal to 1. Negative 4 times negative 4 times 1 times 1, it will give you negative 4 here, divided by 2. x is going to be equal to -1 plus minus root of 1 minus 4. 1 minus 4 here is -3. Negative 3. Negative 3 out of 2. So when you look at this quadratic equation, the final solution here cannot be solved easily because of the root of negative here, because of the root of negative. So you cannot further go to find the root of negative, square root of -3. That's why complex numbers have been introduced to solve this kind of quadratic equations that do not have real number solutions. So there are some of the numbers here. Let's look at this number. When you solve n square is equal to -4. So the value of n is going to be equal to -4 under the square root. So you cannot find the square root of -4 because root of -4 here, root of 4 alone is what? Is 2. But since there is negative inside in the root, it is giving us a non-real number solution. Okay. It is also the same for these complex numbers. So you see inside there is negative number. So it will give you non-real number solution. Real number solution. Remember, the square root of a negative number is not a real number. You see, a square root of a negative number is not a real number. An expanded system called complex number system has been devised to give a meaning to expression like this one here, like this expression. So a complex number has been introduced to give solutions for these numbers which have negative numbers under root. So this brings us to understanding of a complex numbers, where we say it is a sum of real part and imaginary part. So this brings us to conclusion by saying that complex numbers consist of two parts. A complex number consists of two parts, real part and imaginary part. We know that complex numbers, they are also the building block of intricate mathematics. For example, algebra. So they are also applied in algebra. They can be applied in many aspects of real life, especially in electronics and electromagnetism. So the standard form of a complex number is a plus b. This is the form of a complex number. A complex number is in this form. Don't forget this form of a complex numbers. It is in form of z is equal to a plus ib. So where z here, we said it is complex number. Z is a complex number. Z is a complex number, and where a is a real part or real number. So this is known as real part, and this ib is imaginary. It is imaginary part. This imaginary part, where I is imaginary number. It is imaginary number. I is imaginary number. So this is the form of complex number. Complex number is in a form of z is equal to a plus ib. So that is the form of complex number, where a is real part and b is imaginary part, and I is representation of imaginary number. Representation of imaginary number. So let's rewrite again in a correct form. Z is equal to A plus IB. This is a form of a complex number. Define complex number. Complex number is a sum. Complex number is a sum of real part and imaginary part. That is complex number. This is a complex number. So the imaginary number, which is I, is defined by a square root of -1. Imaginary part or imaginary number is presented by a square root of a -1. I is defined by root of -1. I is defined by root of -1. Don't forget of that. If you see I in complex numbers, I is just representing root of -1. It is representing square root of -1, and this make it easy for you to solve any number which is under root. So let's bring the other number before in examples, which was given as root of -16. So with this knowledge now, you can easily solve this by saying root of -16 is equal to root of 16 times root of -1, where root of -1 is the same as what? As I. Therefore, you can easily substitute root of -1 with I. But you know root of 16. Root of 16 is what? Is 4. That is right. So 4 times what? Times I. See? 4 times I. And you have solved it. That is how you solve negative numbers that are under a square root. So let's have another example here. Root of -4. How do you solve this? Root of -4 is equal to square root of 4 times -1 inside times -1 inside. This is going to give you root of 4 times root of -1, and you already know that root of -1, square root of -1 is the same as what? The same as I. So you are going to replace it with I. This one with I. What about the square root of 4? The square root of 4 is simply 2. So 2 times I, this is 2I. So this is the result. That is how you solve the negative numbers under the square root. Negative numbers under the square root. In that form of complex numbers where z is equal to a plus ib, in this form, one of the parts can be 0. One of the parts can be 0. Each part could be 0. Each part could be 0. Any real number is also called complex number. Any real number is also called complex number. For example, 3. 3 can be a complex number. That means it means that it is only real part that is there. Real part that is there. It can be written as z is equal to 3 plus 0I. So the imaginary part here is 0 for 3. Imaginary part is 0. So any real number can be a complex number. Complex numbers being called complex does not mean that they are complicated. Does not mean that complex numbers are complicated. It means that it has what? two types of numbers combined together. It means that two numbers have been combined together, like housing complex, a group of buildings joined together, a group of buildings joined together. So, and that's why we call it a complex number, because there are types of numbers connected together, being brought together, real number and imaginary number. So don't say if it is complex it is hard. It is not so. Real numbers are tangible values that can be plotted on horizontal lines. When you are plotting a complex number, a real part is plotted on horizontal line as fractions. They can be plotted as fractions, integers, or any number that you can think of. While imaginary numbers here are abstract concepts that can be used when you need a square root of a negative numbers. So you can plot them on vertical axis. When we draw two lines, this horizontal line here, and the vertical lines here. So complex numbers are plotted in this coordinate plane. So the real numbers here are plotted on horizontal line. They are plotted on horizontal line. Real numbers, they are plotted on horizontal line. You have to know that. So horizontal line is a line where real numbers are plotted when you come to coordinate plane. Imaginary numbers are plotted on vertical line. This vertical line, it is where imaginary numbers are plotted on the vertical line. A complex number is an algebraic extension of ordinary real number by imaginary number. So here we know I is equal to root of negative 1. I is equal to the square root of negative 1. Okay, if I is equal to root of negative 1, what about I square? What about I square? So I square is going to be equal to root of negative 1 square. I alone is root of negative 1. What about this square? We are going to bring it up here, the square. So this root cancel with the square outside. It remains as what? It remains as negative 1. It remains as negative 1. You need to keep that in mind, that I square is equal to negative 1, because this one you are going to use it in operations of complex numbers. Finally, you should learn how to get the square root of a negative number. Like the square root of negative 25 is 5i. How did it happen? We separate the negative 1 inside there, that is being multiplied by root of 25. So then we represent negative 1 by I, and you already know square root of 25 is 5. Then finally you will have 5i. Then what about for root of negative 81? You separate the two square roots, the square root of 81 and square root of negative 1 being multiplied together. Therefore you will have 81, which is what? Which is 9. The square root of 81 is 9, and root of negative 1 is equal to I. So, and this is going to be your final result. How do we solve this number? If you have negative root of negative 50, this is equal to negative outside root of 50. Root of 50 is the same as what? As 25 times 2 times negative 1. So for this case, you know the square root of what? Of 25 is 5. The square root of 25 is 5. So you are going to have negative, you are going to have negative 5. Then there is no square root of 2. You are going to have root of 2. Then what about negative 1 is equal to I. The final result is going to be negative 5 root of 2I for this one here. This one here is incorrect. So before we go to Argand diagram, so I need to show you some simplifications here. How to simplify complex numbers. Assuming you are given a complex number I raised power 3. So how do you simplify this? So you say that this one is equal to I. So in indices, you know, numbers of the same basis, you add their powers. For I raised power 3, it is equal to I raised power 2 times I alone. If you decide to take it back here, you can add the powers here, and then you take only one base. You will have I raised power 3. So for now we are simplifying. This. You know already that I raised power 2 is equal to negative 1. I raised power 2 is equal to negative 1. What you will do here, you will substitute it here. You will have negative 1 times I, which is going to be negative I. So that is how you can simplify this question. Okay, what about if we were having I raised power 10? Let's say I raised power 10 is equal to I raised power 10 is equal to I raised power 2. Then you multiply the power by what? By 5. For this one here, you can easily change it to be I raised power 2 times 5 is what? Is 10, which is this form. But now you are being told to simplify it. What you will do, you will simplify what is inside there. I raised power 2, you know it already is negative 1. So replace it with negative 1. Raised power what? Power 5. Any number that is raised power odd number, for example 5 here, negative will not change. So this is going to give you negative 1. You will have negative 1 as your answer, negative 1. That is how you can simplify it. Your aim is to first your aim is to simplify I. Okay, let's come to a last example. So if we have I raised power 21, let's say I raised power 21 is equal to I. What you do here, since it is raised power odd number, you need to first have I, which is raised power even number, then times that one odd number. You will have I raised power 20 times I raised power 1, or just I. Then as you have reached to this level, you can easily simplify it. For this, you will have I raised power 2. And then what can you think of a number that you multiply by 2 to give you what? To give you 20 here. So what number is that? It is 10, is it? 2 times 10 will give you 20. Then times I, this I here, times this I, don't forget of it. Now if you have reached to this part, substitute this I raised power 2 with a negative 1 raised to power 10. Then times I. When any number is raised to power even number, it will give you positive number afterwards, whether it is negative or positive. Therefore, for this one here, we are going to have 1. Negative 1 raised to power 10 is equal to 1 times I. The final solution here is I for that one. That is simplification. That is how you simplify complex numbers of this form. So, and B, when any complex number is raised power odd number, so what you have to do is to separate two i's. One I having exponent of even number and the other one, you just separate only one I out. Then after having it in this form, you raise I to power 2, and then you think of number that you multiply by 2 to give you this number and put it outside the bracket. Then you simplify, you replace the value of I raised power 2. So that is it. If it is even number, assuming this one was 20 alone like this, what you would do here was you just go straight, you only raise that I to power 2, and then you think of number that you multiply by 2 to give you 20, and that number is 10. Put it outside the bracket, and then you replace I square with its value. So that is it. Thank you so much for watching this video. Please like, share, and make sure you subscribe to our YouTube channel for more videos. South Sudan education first, sharing is caring.